So there was a comment here to go into more detail on 393. Again, I'm sorry I didn't see this because I went into the spam. So let's have a look at this now. Yeah, it was calculate this limit here. So I'll just write L equals the limit as x tends to 0 from the right, x power 1 over x. Now, if you want, you can think about it like this. F of x equals x power 1 over x. So we can just say this is the limit of this function I'm calling f of x. Just calling this guy here f of x, where f of x equals the function in question. It'd be nice to take the log of it. So if you take the natural log of f of x, that would be the natural log of x power 1 over x. And one of the rules of logs states that 1 over x can come down, the power can come down in front. So that would become 1 over x times log x. Now, if you take x going to 0 plus, we know, this is well known, that if x goes to 0, this will go to infinity. But more importantly, it'll go to the positive infinity because x is staying positive as it heads towards 0. And the same thing happens for log as well. As x goes to 0 from the right, this will go to minus infinity. So we have a situation where we have two numbers going to infinity, one positive and one negative, and a positive by negative is a negative. So this here in total is going to go to minus infinity as x goes to positive 0, so to speak. So the limit as x goes to positive 0 of log f of x, that's going to be minus infinity. That's what we just established here. Now, how does that get us the limit that we want without the log? Well, the only way a log could be negative infinity or going towards negative infinity is if this piece here is going to positive 0. This can only go to negative infinity if this is going to a positive 0. So that means then this here must be going to 0, but from the right. So in other words, i.e. going to 0. So the limit would be 0. So that would be L. Now, if we want a little bit of convincing, let's make a graph here. So if I have here x power 1 over x, and I graph this, you can see it does go to 0 quite rapidly, as we can see. Heading right into 0 there. So that's, yep, that's the situation we're in right now. And I believe that's what I said in the video. Yeah, limit is 0 then. So, yep, there we go.